Hey, hello everybody. Welcome back to Jack's Technologies. Guys, today I'm going to show you how to create REST bus simulation using Python. How do you create REST bus simulation using Python? What is REST bus simulation? Why do we need it? Guys, this is the Keno tool, right? So when I start the measurement, if you observe, the messages and signals are flowing over the CAN with respective periodicity. How these are flowing with respective periodicity and with what values it is flowing. The messages are flowing over the CAN with default values. Okay, how you are assigning the default values and how these messages are getting transmitted over the CAN periodically using REST bus simulation. Who created this REST bus simulation? The test engineers will create this REST bus simulation by using the CAPL script. Now through REST bus simulation, the messages are getting transmitted over the CAN with default values. Now guys, if you want to test some functionality, then what you have to do? You have to dynamically update the values. How do you dynamically update the values? You can dynamically update the values through panels or through CAPL script, right? So you can keep on changing the values. This REST bus simulation has to capture that value and it should help us to transmit the updated values over the CAN. That's why REST bus simulation is needed. Let's say, for example, if there is no REST bus simulation, you can update the value through the test case. Only one time the message will go to the CAN along with the updated value. But the receiver has to receive the value periodically. Okay, then it can send the output. Got it? So that's why we need REST bus simulation. Now guys, we need to create the REST bus simulation using Python. Okay, for which interface we have to create the REST bus simulation? We need to create the REST bus simulation for the interface of PCAN. As I am using the PCAN hardware, so that I need to create the REST bus simulation for the PCAN. So whenever I want to automate any test cases through PCAN, the REST bus simulation is needed so that through other files I can dynamically update the values, right? So now I'll explain you how to create the REST bus simulation with Python. Okay, right. Let's get started. Now guys, to create REST bus simulation, we just need to import these modules. Okay, what is this CAN? This is Python CAN. This is tools. How to import that, guys? Look at here. So you have to import Python CAN. Okay, what is this Python CAN? Why do we need to use this? Guys, Python CAN will help you to send the messages over the PCAN and receive the messages over the PCAN. Not only through PCAN, it support multiple interfaces like PCAN, socket CAN, many things. Okay, to send the messages, to receive the messages. Okay, and also this Python CAN will help you to log the data. Right now, what is CAN tools, guys? If you want to create the REST bus simulation, you just need the input of what are all the messages, what are all the signals we need. So what is the input? You can take the input of Excel sheet where you can have all the details of messages, signals, initial values, periodicity and everything, or else you can use the DBC. In this project, I am going to use the DBC. Okay, as I am going to use the DBC, this CAN tools library will help us to extract the data from the DBC. What data we will extract, that I will show you now. Okay, now I am just importing the time. So to provide some delays. Now guys, I just want to import threading. If needed, I can use this threading. If not needed, I don't use it. Got it? Now guys, before getting into this, guys, if you want to understand this REST bus simulation project, no, you must have understanding of core Python and you must have understanding of advanced Python. You know how list works, how tuple works, how dictionary works. What is list comprehensions, dictionary comprehensions? Okay, if you are aware of all these things, then only you can understand this project. Let's say, for example, if you have very basic understanding or if you have zero understanding of Python, if you try to understand this particular REST bus simulation, you cannot understand anything. Okay. If you want to understand better, you must have the Python skill set. You know how the syntax is, what is, as I said, list comprehensions and everything. Got it? Another point. Guys, also to understand this, you must know how to establish the PCAN bus using Python and how to assign it to channel 1, how to assign 500 kbps baud rate. If you don't know all these things, then again you cannot understand this. Guys, if you want to understand all these things, I have already created a video of how exactly you have to establish the PCAN bus using Python, how to assign the channel, how to assign the 500 kbps baud rate, how to send the message over the PCAN successfully. Got it? If you haven't watched it, the link has been provided in the description. You just go through it, watch it and understand how to establish the PCAN connection using Python. Then you come back here. Got it? Okay, let's get started. Now guys, first of all, what you have to do, whenever you wanted to create a REST bus simulation, first you need input, right? As I said, you need input. What is the input? The input is DBC. Guys, how you load the DBC file? So first thing is loading DBC file. Loading DBC file. Let's understand this. What is loading DBC file? How to load it? So I'm just creating DBC file equals. Guys, you just have to give the path. Where exactly you have the DBC file, that path you have to give. Copy as path, convert it into a raw string, give it. So you have given the path. Now guys, you just need to load this DBC file so that after loading this DBC file, you can extract it. Okay, I'm just creating DB equals. If you want to load the DBC file, which library helps you? CAN tools. CAN tools dot database dot load file. Okay, then you just give the DBC file here. Got it? So now just print like DBC file loaded successfully. Got it? Now guys, if you run this, what you will get? DBC file loaded successfully. You have successfully loaded the DBC file, right? Guys, as you have successfully loaded the DBC file, what is the next part? Now you have to establish the PCAN connection, right? Guys, I have already explained you how to establish the PCAN connection. Okay, look at here. Guys, this is how you have to initialize the PCAN connection. This I have already explained in the previous video. CAN.interface bus channel PCAN PCI bus 1. Interface is PCAN, bitrate is 500 kbps, and I am just printing PCAN bus initialized on channel 1. Guys, I have already explained you how you have to choose this channel name, how you have to give this as an interface, and what is this. You are aware of these things, right? So you have successfully loaded the DBC file and you have initialized the PCAN, right? Now guys, I need to extract all the messages, initial values, signals, and cycle time from this DBC file. First, I need to extract that. How to extract? First, what I do, I'll just try to create an empty dictionary. Okay. Message conflicts. So why I have created this empty dictionary, that we'll see later. Okay. Now guys, first what I have to do, as I have already loaded the DBC, now that DBC has multiple messages. Now I need to iterate through each message. Let's say for example, if we have 10 messages, I need to iterate through each message. And after iterating through each message, what I need to do, I need to print the message name, print the message ID, and then I need to print the cycle time. Okay, right. Let's do that. So what I am doing for message in db.messages. So in database, we have column called messages. Okay. So from the messages field, I am iterating through each message. The message is the temporary variable. So what I am doing, I am just printing processing message dot name. I just want to print the message name here. Got it? Let's take it as a formatted string. Okay. Then what I have to print? Frame ID. Got it? Now, so message dot frame ID. Okay. In CAN tools, we have to use frame ID instead of using message ID. Okay. So I just wanted to print the message ID. Then what I have to print? Then I have to print the cycle time. Cycle time milliseconds. Okay. Use this as a formatted string. Got it? Understood? So I am extracting the DBC file. From the DBC file, I am extracting the message name, frame ID, cycle time. Got it? Now let's run this. Now guys, if you check here, DBC file loaded successfully, PCAN bus initialized on CAN. Now the processing message, the first message is message response. The identifier is 1537. What is this 1537? We are using standard ID. Standard ID is nothing but 11-bit identifier, right? 0 cross something we should get. Why we got this? I'll explain you that. So the cycle time is none. As this is the diagnostic response message, diagnostic request message, there is no cycle time for that, right? Now, if you come to RDS coder data, this is the frame ID, which is message ID. Then this is the cycle time. Now, gear message, okay, processing message, gear message, then ACC BCM message. All the messages I have initialized the cycle time as 50 milliseconds. Got it? Right. Now, guys, here we are getting the frame ID in decimal. I have already explained you the what is typecasting, how to convert the data. Okay. You must understand this. Why? Because whenever we are writing the scripting, typecasting plays a major role. That's why I have already created the typecasting video, right? Now you convert this to hex. The frame ID, you convert this to hex. Now check your output. If you run this, what you are getting? See, the frame ID is 0 cross 601 701 4DD. Got it? Understood? Right. Now guys, once after this, what we have to do? If you want to send the messages periodically, first you need to check what messages has the cycle time, which messages will be transmitted periodically. The messages which has cycle time, those messages will be transmitted periodically. Am I right? Right. So first you need to check the messages which has cycle time, and also you need to check the each signal has the initial value. The messages will be transmitted over the PCAN periodically with the default values only, right? What is the default value? Whatever the initial value we have, that initial value is the default value. Now there are messages and signals which has default values. For few of the signals we don't have any default value. If we don't have default value, we have to assign 0 to it. If we have the default value like 0, 1, 2, then we can transmit the message with that particular default value. Got it? Right. How to check whether the message has cycle time or not? How to check that? If message, so whenever you are iterating through the message, it is checking each message has the cycle time. Okay. So let's say for example in our DBC we have total 5 messages. In 5 messages we have only 3 messages has periodicity. 3 messages has cycle time. So now this condition will become true only 3 times whenever it iterates through the messages which has cycle time. Got it? Now after iterating through the cycle time, now guys, the messages whatever has the cycle time, now we need to check each message has multiple signals. All the signals has the initial value or not. If there is no initial value, assign 0 to it. If there is initial value, just add the initial value to it. For that, what I am going to do, I am going to create a dictionary. Default signals. Now guys, if you want to understand this, you must aware of dictionary comprehensions. How exactly the dictionary comprehension works. Now, these default signals, what I am doing, sig dot name, which means I am adding the signal name, and I am adding the sig dot initial value. What is sig? I'll explain you guys. Now, if sig dot initial is not none, which means the signal initial value is not none, means 0, 1, 2, add that signal name and initial value. If it is not none, then you add it. If it is none, else add 0. Now, you have to get the signal initial values, you have to iterate through each signal in the message. Now here you have the message which has cycle time. You got the message which has cycle time. That message has multiple signals. Now what we have to do, you have to iterate through each signal. So what I am doing for sig in message dot signals. Got it? Now see, so it will iterate through each signal, and each signal will check if the signal dot initial is not none. 0, 1, 2, add the signal name and initial value. If it is none, then add 0 to it. Got it? Now guys, what you do, let's print it. Print default signals. Got it? Now let's run this. Guys, see what you got. Here, these are the diagnostic messages, response and request. There is no initial value. There is no signals here. Okay, leave this. Now RDS coder data has one signal speedometer. Okay, so signal speedometer initial value is 0. Now if you go here, ACC init status signal value is passive. Passive means the ACC init status signal value is 2. As I have showed here, the ACC init status is flowing with the value 2, right? Because 2 means passive. If you open this DBC, then you will get to check this ACC init status. The initial value is 2. 2 means passive. Got it? So what happened here? It has iterated through each message. Each message, signal name added, initial value added, signal name added, initial value added, signal name added, initial value added. Same thing has happened for all the messages which has cycle time. Understood? Understood how to extract the DBC each message, and how to extract each signal and check whether the signal has the initial value or not. If the signal has the initial value, and how you have to add it to a dictionary, and if the signal do not has the initial value which is none, then how you can assign it. Did you understand till here? Okay, now guys, as we have extracted all the details, okay, now what I wanted to do, let's try to get all these things at one place. Got it? So already we have created an empty dictionary, right? Now guys, what I have to do, in this empty dictionary, I will add all these details. How to add it? So what I am doing, message configs. Okay, in the message configs, I'm just passing the key as message.name. So after adding message.name, guys, I am creating a dictionary here. So to this particular message name, I am adding all the properties of that particular message. What are the properties of that particular message? I need to add frame ID, cycle time, and default signals. So already this is a dictionary. So in this dictionary, to the message name, I am adding nested dictionary. Okay. So what I am adding? Just I am adding the key as frame ID. Okay. Message dot frame ID. Got it? Comma. Then I have to add the cycle time. Message dot cycle time. Right? So cycle time, I need to add it in milliseconds so that I am dividing it with 1000. Okay. Then what I have to add? I have all the signals list, right? I need to add those signals list. Default signals. So to these default signals, I am just adding the default signals. Got it? So I just need to separate with comma here. Understood? Now guys, after adding this, if you want, you can print the message configs. Okay. Guys, what I do, let's try to print that. Now guys, if you understand this, see the message name I have added as RDS coder data CAN, and then the frame ID is 1245. Again I am getting as 1245. What I have to do? So just I need to convert into hex. Right? Now run this. Now see in one dictionary, the frame ID is 40D and cycle time is 0.05, which means 50 milliseconds, and default signals. Again, I have added one more nested dictionary, signal speedometer request one. So again the message name, gear message, frame ID, all the properties. ACC BCM message, frame ID, cycle time, all the properties. Got it? So now we have got all the messages into one particular dictionary. Understood? Okay. Now guys, we have extracted the database by using CAN tools library. Now guys, we have to send the message periodically over the CAN. Now we know all the messages and what is the properties of the messages, what is the frame ID, everything we have, cycle time, everything. Now I need to transmit all these messages over the CAN. So first what I have to do, I'm just creating a function here. So I have created a function to send the periodic messages. As I have created a function to send the periodic messages, now guys, first what I need to do. So if you want to make these messages to send to the PCAN with proper periodicity, so this program has to keep on run, right? So what I'm doing, I'm just taking the infinite loop while true. Okay. Now, so now in this message config, I have the message name. This is the message name and this is the message date. I just wanted to take this data separately. So what I am doing for message name, comma, message data in message configs. So from the message configs dictionary, we have the message name and message data. So I need to take the message name and message data. How to separately assign the key and values? We have to use the method called dot items. Okay. Now, so you have separated the message name and you have given the message data to message variable. Each message name it will take and each message data it will take from the message configs. Now guys, what we have to do? So you just print processing to send the message. So if you want to send the message, you have to display the name, right? MSG underscore name. Got it? Now let's take it as a formatted string. Let's run this. If you want to run this, first you have to call this function, right? Let's call this function. Okay. Now if I run this, now if you see processing to send, each message name it is taking. It is taking each message name from the message config. So it is saying that processing to send this message, processing to send this message. Got it? Right. Okay. Now along with this message, I need to transmit the default signal values also. So that I just need to take a copy of dictionary with default signal values. So what I am doing here, signal values equals message data. So message data means this one, right? Other dictionary. So message name and other properties. So from the message data, what I need? Default signals. I just wanted to assign these default signals to the signal values. How can you assign it? You just need to take a copy of it. Okay. Now print signals with default data. Okay. Take it as a formatted string. Now again call this function. If you run this, now see what we are getting. Processing to send one message and along with the default data we are getting. Let's stop this and then I'll show you. See, processing to send the message MO message and signals with default data. Okay. I wanted to send these signals with the default data. Got it? Let's comment this. Now guys, what you have to do after sending these values, you have to encode these signal values. So as you have to encode this signal value, how you can encode the signal value? Why signal encoding is needed? Guys, you wanted to encode the signal value. So here you have the 0 value, 1 value, 2 value and all, right? The PCAN will understand only binary values. So you have to encode the signal values. Encoding the signal values means signal data you are trying to convert into binary. So that binary data will be transmitted over the PCAN. Got it? So each signal value you have to encode. Okay. Now guys, how to encode this data? Just like this. Okay, I am taking the variable as encoded data db.get message by name. So I need to get the message name and encode. So to that message name, whatever the signal values we have, all the signal values we have to encode. So whenever you encode the signal data, you just print that particular encoded data. So when you print that encoded data, now let's stop the tool. So now see here. So the signal values, see ACC init status is value to 0 0. So it has converted into binary. Okay. So binary x020000. If the data you have default value 00, whenever you change the data, it will take it as 02. Got it? So in this way, it has to encode the data. Okay. Now guys, after encoding the data, what we have to do? We have to send the CAN message over the PCAN. Guys, how to send the CAN message over the PCAN? You know, right? How to send the CAN message over the PCAN. If you want to send the CAN message over the PCAN, first you have to create a CAN frame. If you create a CAN frame, then only you can send the CAN message over the PCAN. How you have to create, guys? This also I have already explained in the previous video. Python plus PCAN. How to send CAN messages easily. Now see, I have taken a variable called CAN message, CAN dot message. Okay, CAN dot message. Now I need to give the arbitration ID. Guys, arbitration ID. How I can give? From the message data. So here we have taken the message data, right? Message data means message properties. From the message data, I am just giving the frame ID. Okay, and data, what data I need to send for that particular message, whatever the data I have encoded, that I need to give. And here I am giving it as false, which means I am not using extended ID, I am using the standard CAN ID. Got it? Once you create a frame, how to send the message over the CAN? Bus dot send off CAN message. Got it? So you have transmitted the message over the CAN. This is how you have to transmit the message over the CAN. Now guys, as it is iterating through each message has to flow with proper periodicity. Few messages will be having 50 milliseconds, few messages will be having 200 milliseconds, few messages will be having 300 milliseconds periodicity. How can you achieve this? So that you just have to provide some delay. How much time you have to delay? Whatever the cycle time you have for this particular message. Let's say for example, here the message is getting transmitted as MO message 1. MO message 1 in message data, we have already cycle time. So you have to provide delay of that cycle time, right? How to provide delay? Time dot sleep off. From the message data, you have to capture the cycle time. Okay, this is the cycle time. So you just, so whenever you are sending the message, that message cycle time it will extract. As it has extracted that message cycle time, then it will provide delay. Let's say for example, that message cycle time is message dot cycle time returns 50, then time dot sleep of 0.05, which means 50 milliseconds. Got it? This is how you have to transmit the message over the CAN with proper periodicity. Whatever the message is getting transmitted, that cycle time will be assigned here, and it will wait until that cycle time. Then again the message will be transmitted over the CAN. Now guys, what you have to do now, call this send periodic message. Okay, now guys, what we do, let's run this. So when you run this, guys, I have got error here, arbitration ID. Okay, so it is saying that string object does not interpreted as an integer. Guys, what I did here, I have converted into hex, right? To just print it. Let's remove hex here. Because the arbitration ID, it will take the integer value only and it will convert into hex value. So that when you run this, now I got one error which is cycle time. What is cycle time? Here I have taken the cycle time. Maybe the naming convention is wrong. Okay, the cycle time I have defined this way in message configs, right? So I just need to add this cycle time, right? Now. Okay, right. Now guys, look at here. The messages are flowing periodically over the canvas, okay, along with the cycle time. So each message is getting transmitted with the proper periodicity. Each message is getting transmitted with the proper periodicity. So the time delay is happening because of the cycle time, whatever we have given here. So each message, whenever it has iterated through the each message will flow to the CAN network with proper periodicity, right? Now, guys, this is how you have to send the messages periodically. Now, as you are not receiving the messages, I just called the function here. If you are receiving the messages, then you just have to use the multi-threading here. If you are using the multi-threading, then you can transmit and receive messages properly. As of now, multi-threading is not required. Our intention is to transmit the messages over the PCAN periodically. So this is how we have to create the REST bus simulation, right? Okay, guys. Now I have just called this function because I am not doing the multitasking here, like sending the messages, receiving the messages. I am not doing multitasking here, so that I am not using threading. Okay. So in the next video, I'll just try to explain how exactly you have to use the threading here, why exactly threading is needed. That I'll explain you in the next video. Guys, let's try to check whether our messages are flowing over the PCAN successfully or not. I have just opened PCAN and I have taken the channel one. See, the messages are flowing. Now guys, see, all the messages are flowing with the proper periodicity. Whatever I have transmitted through the Python file, all the messages are getting transmitted in the PCAN view. But you can see all the messages are getting transmitted as RX. So you should observe it as a TX. Right? Okay. This is a different story and very big story. This concept we have covered in our advanced Python courses, right? Guys, if you want to enroll for our Python courses, you just try to contact the below numbers whatever we have provided in the description, right? Hmm. Guys, that's it for today. I think I have successfully explained you how exactly to create a rest bus simulation for your PCAN so that you can directly transmit the messages along with the respective periodicities. Got it? If you found this video helpful, try to share it with your friends so that those people also will learn how exactly to create the rest bus simulation using Python. Got it? Okay guys, thanks a lot. Thank you for watching this video. I'll catch you in the next video. Until then, see you and bye bye.